Good afternoon, everyone, and welcome to our energy technology series. I'm glad you could join us today.
Absolutely. Thank you, John, and welcome, everyone. Appreciate you attending today. As a very quick background on Bradley, we are a Southeast-based law firm with a national presence focused on providing elite service to our clients. I'm a partner in Bradley's Charlotte office and is co-chair of our renewable energy team. I'm proud to be involved in E4 Carolinas and honored to sponsor E4's Energy Technology Series, featuring leaders in energy tech sharing their cutting-edge solutions to many of today's most pressing industry problems. Today, of course, we are pleased to welcome SolarOps to the Energy Technology Series. SolarOps is a leader in the energy transition with its development of hardware and software solutions addressing challenges in solar interconnection. So without further ado, I'll introduce Brad Mcauliffe. Mcauliffe, thank you very much. Again, I need pronunciation assistance. Brad Mcauliffe, welcome, Brad. Brad is a veteran of the utility scale solar industry and has supported over 3 gigs of transmission and distribution interconnected renewable projects since 2008, while working for industry leaders including First Solar, Capital Dynamics, and Depcom Power. Founded in 2015, Solar Operations Solutions LLC was created to develop and demonstrate a more efficient and effective operations and maintenance model to address the growing number of distributed renewable energy facilities. Informed by the self-management of a 100-megawatt North Carolina-based portfolio of qualified solar facilities, SolarOps created a highly optimized technology platform called MyPV to accomplish these business goals. Commercially available since 2018, MyPV provides monitoring, control, and integration capabilities that are both software and hardware-based, supporting the rapid and reliable development of renewable energy projects. So, Brad, thank you so much for your time today, and we're looking forward to hearing more about SolarOps and your particular technology niche. I will turn it over to you and appreciate it.
All right. Monica, thank you very much. All right. Well, thank you very much. I will try to run through this at a reasonable pace, and we're going to cover at least what I think are some of the most important aspects of O&M for both distributed renewable energy resources as well as just kind of best practices here. Try not to focus on the hardware and technology too much. These are things that a lot of people could implement with appropriate planning here. So without further ado, I'll introduce myself, although I think this is largely a rehash. My name is Brad Mcauliffe. I'm president and COO of Solar Operations Solutions. I've been in North Carolina for the past 7 years, working with IPPs and numerous companies across the country. My background is actually in automotive manufacturing prior to coming to solar a little bit over 14 and a half years ago. And I never have a boring day in this industry. I enjoy the challenge. And of course, if I had a choice to put another car on the road or more solar on the earth, I will choose solar. So with that, taking a look at how O&M plays out with distributed renewable energy resources, there's some real unique challenges that are different from traditional resources. One is there's a very large amount of variation. Projects are micro to massive in size, and you need completely different optimization, performance engineering, and maintenance plans. We have a lot of new equipment providers coming into the space literally on a monthly basis sometimes, and also equipment providers leaving the space where support and parts are no longer available. Solar can be configured in a lot of different ways, from simple to complex. And so it's not a one-size-fits-all strategy. Whoops. Let's see. All right. These facilities are remote, so they distributed. And so you have very rural locations where you don't have a lot of people or resources around them in a lot of cases. Things are spread out, they're hard to get to, and even just trying to plan on how to get technicians to all these facilities can be very challenging in a timely fashion. And then, of course, they're built in what I will generously call a cost-optimized fashion. People are not always thinking of the long term of what might I do with this asset 10 years from now, or should I add an extra disconnect switch, or would it be handy if I could get to something when it breaks? They tend to build things based on more of a budget driven delivery. There's a lot of focus on selecting components like inverters and modules, not necessarily how the overall system will operate as a whole. And then because these assets are bought and then sold most of the time, the long-term owner, whether it be a utility, an IPP, or some other type of yield co, they arrive late. And so even if they have more practiced and more mature policies of how they might have built something or what the standards are, a lot of times the solar facility is already built. And the same is true with storage, as those are coming online very quickly. So how do we tackle this problem? So we ourselves, just to reemphasize, we are not only a software and hardware technology provider, we are an O&M provider. We primarily operate in the Southeast, in the Carolinas, and as it was mentioned, we have about 100 megawatts across 27 facilities that we operate with a relatively small crew of people. We're able to keep very high availability, through our systems, which is what we're going to walk through today a little bit, and give some examples of how you can make solar very reliable and ultimately return not only the financial yields, but the societal gains that we're all looking for as we transition to clean energy. So a typical approach to O&M in solar is fairly simple. We've bought a bunch of equipment and they all have annual maintenance requirements. And then I'm going to go and hire some technicians, mostly with electrical skills, to go out and perform that annual maintenance. I'm going to have a monitoring and alarming system, which is going to tell me when something is wrong and allow me to see what's going on. And then, either out of obligation or my own curiosity, I'm going to have some periodic performance reporting. So it's pretty basic on paper, right? Build it, get qualified people, give them data, and report on it. Unfortunately, because of all that variation and remote operation and late ownership, this doesn't come together necessarily as well as people would hope. That transition out of construction and commissioning to the O&M provider usually lacks what we would call good, solid documentation. The actual maintenance schedule itself is usually overly optimistic when you start to consider that you have plants spread out all over, sometimes multiple states. When technicians, even if they're very skilled and very knowledgeable, arrive to sites, they usually don't have the information that they need to really understand what is going on. And so they spend time hunting around, looking for problems. They arrive without necessary parts or tools. So there's a lot of specialty parts and tools necessary for all this different type of equipment. A lot of times we spend time troubleshooting components versus systems and how they're interacting with each other. The monitoring and alarming systems are very good at collecting data, but not necessarily providing information. And some of the conditions that arise on these sites don't necessarily render fault codes. For instance, a very basic one, if a medium voltage breaker trips, a trip is not really a fault, even though your site's offline. And so, in fact, the breaker did exactly what it was supposed to do. So, and this then, of course, leads to some of the other problems in the industry where when we have performance reporting, all of this kind of lack of information and not knowing what's going on in the field in a timely manner. We have lack of specificity in the reporting, unexplainable performance issues that tend to be grouped into a bucket of what they just call, poor weather or lack of solar fuel. And then, of course, the reports are delayed because all of this data and all of these logs from the field need to be compiled into reports. So this is not scalable, and yet this is exactly how a lot of O&M providers kind of find themselves operating as they move from 2 or 3 sites, which was manageable, to 10 to 20 to 30, et cetera. So we're going to take a little bit different approach to this here today and show you how we've approached this issue. So first, we're going to reorder kind of the priority of these 4 basic elements. So we're going to move monitoring and alarming up front, and we're going to change it a little bit. So what we really want is we want monitoring with control, and we'll talk about why that's important in a second. And we want this to not just give us data, but we want analysis with this. So we don't want to have to look at a bunch of raw data. We want to know what the problems are and where they are. Along with this, we're going to establish what's called master data. And that's not necessarily an IT term, that's just documentation. We'll talk about that in just a second. We also, again, want to not just look at raw data, but we want to look at key performance indicators, or KPIs. And so think about going to the doctor and, they don't ask you about all of your blood work right off. They ask you, how do you feel? Do you have a temperature, right? They listen to your heart. And so those KPIs are things we want to identify. We want to be able to have control so that we don't always have to send someone to the field. We want to be able to reset faults remotely, and we want to be able to make sure that the plants are operating reliably as quickly as possible. We want to change this paradigm of periodic reporting to continuous reporting. So we want the systems to be able to tell us in real time what's happening with the site so that we can react and we can remain situationally aware. So establishing real-time system awareness. When we do send maintenance into the field, we want to be able to prioritize it, whether it be by safety or energy yield. And we want to be able to group maintenance whenever we can. So if someone is making a trip all the way out to the coast, for instance, or all the way up to Virginia, we want to make sure that they can either hit other facilities on the way back or hit facilities on the way there, maybe even just deliver parts for somebody else. And then we want to do what's called kitting maintenance responses. And the concept of kitting here is we want to make sure that when a technician goes to the site, they have the information, the materials, and the tools, and the skills that they need to actually resolve the most likely issue. It keeps opening on me. Okay, we don't just want to schedule maintenance, we want to look at maintenance very holistically. And so even though solar, forever, when I've been in this industry, I was always told solar has no moving parts. Nothing will ever fail. And I wish that were true. But solar, like anything, is both electrical and mechanical, and it sits outside. And in fact, lots of things fail all the time. Luckily, they're typically very small things. But we want to plan for that. And so we want to build in an allowance for corrective maintenance. That's what we call when things break and fix, and they're not just preventative in nature. We call it corrective. And we want to be able to manage that in our schedule as what we call a buffer. We want to try not to react to failures and just get real excited and send people someplace because there's a problem. We want to plan for that so that, again, that response is kitted and we're sending the right people. And if we're on site already, we want to minimize windshield time. If somebody's there, we want to try to have them do as much at that facility while they're there, while they're already on site. Technicians being qualified is a common term, qualified personnel, but we want them to be a step further. We want them to be knowledgeable. So we want to provide them not just component or device level training, we want to provide them system level training. How do all these things interact and work together? How do they work with the grid? We want to qualify them for more skill sets than just things like AC and DC, which is where most technicians have a lot of experience, alternating in direct current. We also want to train them for medium voltage, even if they're not the ones not making the repairs. We want them to understand how the grid works, how the transformers work, how all those components overhead work. We also want to make them IT people. They need to know how all these components are networked together and talk to each other, because there are a whole host of failure modes that look like generation problems, but in fact, sometimes they're just communication. And then, of course, most importantly, last but not least, we want to promote live field to office communications. So often we will see maintenance people go out into the field and they will simply come back with a report at the end of the day or the end of the week. But we want to make sure that people are on the phone talking to each other so that, other people can ask questions and learn, and there's more eyes on the problem. So let's walk through these. All right. So establishing master data, whether it's a spreadsheet or Dropbox or SharePoint or something else, there needs to be a source of truth for all these facilities in your organization in order to track what equipment do you have, what is your warranty status, what are the serial numbers, what are all the attributes to it, it's AC, DC capacity, etc. You can't be too organized in this case. You want to build up a library of equipment manuals. When something breaks, the last thing you want to do is have to go searching for a specification on a fuse or a relay, or what does this error code mean? So establishing master data. is something that we try to encourage with all of our clients and, of course, in our products as well. Defining KPIs. So without telling you what our KPIs are, we promote this through some of our offerings where you can't necessarily look at every voltage or current reading on an inverter all the time, especially when there are maybe hundreds of inverters at a site. But we try to break facilities down where we have indicator lights that are more akin to what you might find on the dashboard of your car. So everybody knows what a battery or an oil light looks like, or a low tire pressure light. For us, this is data, fuel, performance, and inverters. And for sites that have batteries, we even have a space for a battery icon here to show state of charge. But using both color and shape and exposing data through rollovers, we can monitor both those microsites, whether it's just on a rooftop, all the way up to mega utility scale sites, using a very common uniform control. And this allows us at a glance to see where we have problems. We want to minimize shortfalls. So now that we can see where the problems are, it's important to be able to do something about them. And this is where control is something that we really try to emphasize with people, that if you're just monitoring your sites with data, because maybe you did not think your solar site had any type of generation requirements with the utility, that's typically where people think of control. But we try to emphasize the need that there are really good cases for having control, and we're going to walk through one here in a second. The three most common uses of control for O&M is remote recloser, trip and close operations. And we're actually going to look at that right here. This is actually a recloser trip and a recloser restore, and we were able to do that remotely. Remote inverter fault resets. So not all faults on inverters require a technician to touch it. And if an inverter can be put back into service, you are literally enabling the inverter to continue operating until a technician can get there to perform a deeper analysis and saving that energy yield. And then with trackers. Trackers also probably one of the most mechanical portions on a solar site these days, sometimes with hundreds of motors. All of those motors and batteries and wireless comms cards, they all can have failures, and they do. And so when trackers are not operating properly, the ability to change their mode from wash or stow mode, or the ability to reset a fault, is terribly, terribly important to preserving reliability of these sites for the grid. So let's talk about continuous performance reporting. So now that I have all this great data and I have this real-time analysis and information that I can act on, let's take a look at what can happen here. And this was a real situation that actually happened back on the 1st of April. So we had a trip event. When our inverters were generating, we see this green energy, and this red that you see, this is the expected generation at the site. And you can see that we're basically losing energy. That's what this red represents. So we had a trip, a fault of some type, and we received an alarm. Our operators were then able to remotely access the site through a secure interface, and they were able to actually verify that fault event. So again, without anybody having to go to the site. Over the course of the morning, we were in communication with the utility from our operations center in order to understand that there had been a utility side fault. And once that fault was cleared, we had requested permission to close our facility back in. And once we received that permission, we were able to use this control tile right here in order to send a close command and verify that it had actually closed. And you can see that the site came back online. So in normal cases, this would be the end of this story. But in this particular case, this fault event actually caused another fault on the site. And so let's take a look at what happened here. So we're still missing some energy, some power production on site. So looking at a few other pieces of information that we have available to us, we're looking at the 3 inverters on site as they operated during the day. And so they started up, and then we had our recloser trip event, and all 3 inverters came offline, and the entire site was offline. But when we closed that recloser, inverter B did not come back. And so it stopped generating. So again, using some tools here, we were able to take a look at what happened with that inverter. And so it was throwing a critical fault. And again, back to that concept of master data, so that we didn't have to go digging around inside of a file someplace. It told us that critical fault code 7 is actually a power supply number 8, and it has failed. And that's great to know. Unfortunately, we didn't have power supply number 8 on Friday, the first, when this took place, but we were able to order it, and we were able to get it on site for Monday. And that's what you're seeing here. Is this is the 4th on Monday, and we received the part, dispatched our technician, and we were able to restore the inverter. And so this is a great example of being able to use information coupled with remote control of the sites, and then efficient prioritization and grouping, in this case, of your maintenance deployments, so that we didn't have to send a technician Friday. We didn't try to deploy somebody over the weekend to figure out what was going on. When our technician left Monday morning on their way to another site, they were able to get to the site, make the repair, and then continue the rest of their week as if this had never happened. All right. So the other thing then that we can do with that information, we talked about reporting and the need to be able to continuously have performance reporting. So with this information, we can also look and we can see how the plant was performing before. This orange line is what we call the expected. This is the weather adjusted model in this case. And we can see we were overperforming the day before the fault. And we can see that we're back to overperforming the day after the fault as well. So those are great. So the days in between then, the first when we had our site outage, and then when we had inverter B offline until we could get that part there, we have a difference between the expected and the actual, and that is our loss. And so we can quantify that loss very easily. The same information that was used to draw this graph can be used to very quickly show how much energy was lost. And of course, if you knew what your PPA or REC price was, it's simply a matter of multiplying your kilowatt hours by your commercial values to get your loss there. All right. So talking about maintenance then, if I have all this information, if I'm trying to figure out where to send technicians to, how do I do that efficiently? So if we were to look at maintenance in the same way that we look at an office worker, they're going to come in for an 8-hour day, essentially, Monday through Friday. And that's great if you're always coming to the same place and always leaving from the same place and don't necessarily have a lot of surprises during the week. Maintenance is full of surprises. So we want to build some buffer into how we plan our weeks with our technicians. So the first thing that we do is we offer our technicians a 4-day work week, 10 hours a day. And the basic idea here is we don't want to have to drive 5 times to get to work. If we only have to drive there 4 times to get to work and leave and stay at hotels, it's less windshield time. Once a technician's at a site performing either annual or corrective maintenance, they're there. They have their tools. They have their PPE on. They've already done their job hazard analysis. So as long as weather will permit and as long as it makes sense, we want to keep them working while they're there. It is simply more efficient. The other thing we want to do is we still want full coverage here during the week. So we split our maintenance team into essentially the A team and in our case, the B team. This could be a lot more complicated depending on how many people you have. But what this does then is for our A team, because they're not normally scheduled to be there on Fridays, we have essentially an extra day for the A team that if we had to deploy them, we could. Likewise, for the B team that doesn't start till Tuesday, if something happened over the weekend and we needed to deploy them a day early, we can do that as well. And so, granted, there's some labor aspects to this with overtime or maybe asking somebody to, could you do 10 hours today but not do 10 hours later? But the reality here is if we plan our annual maintenance schedule, which usually takes up a fair amount of our year, This gives us time that we can negotiate with in our organization to deal with corrective maintenance issues when they come up without actually having to depart from our annual maintenance plan. Aside from just doing some basic labor shifting, we want to make sure that as failures happen, we are not simply saying, hey, stop what you're doing and immediately run over here. Granted, that happens sometimes if it's a safety issue, if it's a very large fault, but we really want to try to keep people efficiently working on the things that they're working on as often as possible. So this is actually a map of the facilities that we have in North Carolina and in Virginia. And we're located right up here, just north of Charlotte. So we're not really close to a lot of our facilities. And our technicians, as hard as we tried to hire technicians that live close to where the sites are, the reality is they live over here too. And so this is a real world management case. So thinking about how to plan for these, it's very apparent that you need to have some type of a grouping. Excuse me. And so often, I think people look at the sites or the facility locations and say, well, we will simply group these, the ones that are closest to each other we'll put together. And that certainly is a way to do it. And depending on how your technicians, where they're located, that may work really well for you. We found it doesn't work real well for us. The reality of it, if you can see my mouse, is if they leave and drive all the way up here to Virginia and I have all my techs up here working, but all of a sudden I get a fault down here, I have to essentially, cross state travel to get there. And then they have to cross state travel all the way back to get back. So this can become really inefficient if you're trying to deal with issues. So we look at our fleet slightly differently. We look at things from distance, and then we try to group the facilities by how far away are these. And some of these groupings look similar. They're not exactly the same, but notice that even some of these, we kind of look radially here. And we plan to do the farthest facilities away from us the earliest in the year. So why would we do that? So it's pretty simple. In the beginning of the year, everything's very optimistic. We're not behind. We haven't built up a lot of the problems that tend to occur during the year. So as we travel out to these farthest facilities, if there are issues that come up, it's pretty easy to just send someone back. They have to come back anyway, eventually at the end of the week. And throughout the course of the year, as these farther facilities, the annual maintenance is done and they are in their best condition for the year, least likely to have problems, we are actually reducing our daily deployment and return timeframes, essentially making our days shorter. And so as more problems come up over the year, we tend to have to deploy shorter distances in order to be able to get to different assets. So if we look at an example, I have two facilities that have a problem here. And so using my Team A and Team B concept, I can deploy them each to where those problems are on their way to the farthest facilities where I'm trying to do annual maintenance. And while they're at these facilities, we want them to be very opportunistic. We want them to try to do any other items that are there, change filters, check fire extinguisher pressures, make sure gate signs are hung. Those are things we can check off of our annual maintenance list so that we don't have to do them later. When they are done with annual maintenance, though, at these plants that are far out, and they're coming back at the end of the week or even midweek, we also now have a lot of facilities along the way. And so if there were small issues that came up that were not necessarily emergencies, but they were eroding performance, we can take care of these things as part of our normal business simply by extending the week by 1 day for people and not getting into their weekends. And so simply looking at how we maintenance plan and how we group our facilities together has made a huge difference in our efficiency of operations. Okay, so talking about knowledgeable technicians then. So we don't just want to train for individual pieces of equipment. We really want to train for how these things work together. So after safety, And after component level training, we want to provide what we call experiential training. We want our technicians to understand how all these components work together as a whole. And the best way that we found to do this is to involve the O&M team in the actual commissioning, and also the initial energization process. This is when none of these components are working the first time. And so you have not only the construction crews there, but sometimes manufacturer representatives on site working through troubleshooting issues and verifying things. And it is the best form of training that we have found, informal training anyway, in order to provide insight into how these things work together as a system. The other thing then that we emphasize is training on what I like to call the boundary disciplines. So a solar site is typically 600 volts and below on the AC side and 1500 volts and below on the DC side. But most solar technicians, if you were to talk to them about how a transformer works on the medium voltage side or what components are on the medium voltage overhead connections, most of them don't know what those things are. And in a lot of cases, they've simply been told they're dangerous and they should stay away from them. And I think for the general public, that's really good, safe messaging. Don't mess with medium voltage. But when you're a technician and you're on a site and you're trying to understand how your facility interacts with the grid, there is a line of being able to have a respect for the safety of that equipment and at the same time have an understanding of how it works. That's not to say that you'll ever operate it or you'll ever climb in a bucket truck, but being able to identify components and understand what their purpose is and understanding how they might lead to a fault condition on your site is important. Caroline, one of our operations staff, by the way, is actually at medium voltage training here. And a former technician, Kimberly, is actually training some of our new technicians on IT and networking. So not necessarily traditional solar type of things, but all of these things together make the system work. And it's important, again, from a system standpoint, that we understand what those are and how they interact so that when we see a problem, we can understand, is it a component failure or is it a system failure? Communication. So here again, when we think of maintenance out in the field and when we think of operations, it's very easy to see these are very different environments, different tools, different working environment, just different working in general. We want to make sure that these two groups of people are absolutely communicating all the time. And so when troubleshooting is happening in the field, we want to make sure that the operations team is on the phone and they're actually verifying that, yes, I see the same measurements that you do, or you just turned on an inverter. Okay, do I see it coming on in the system? You just turned something off. Do I see that turning off? Is it the right thing? So often we see things that are mislabeled, where they're labeled, they're called, 1, 2, 3 in the field, and in the system, they're actually 5, 6, 7. And that leads to all sorts of safety concerns. And so, so just this ability to work together and get more eyes on the problem, pull up documentation. In the field, it's very difficult to use all those resources sometimes when your hands are full and you're focused on safety of yourself and the system. So we want to promote communication. All right. So all of these things together, whether it be from the monitoring, control, and analysis side, less data mining and actually having actionable data, continuous performance monitoring, not waiting until the end of the month or the quarter to understand if something is offline or where your faults might be, a real-time view. Planning for corrective maintenance in your annual maintenance schedule, just knowing things are going to break. We need to run the organization in a way that should not be a surprise to us and it should not derail our timelines. And then, of course, taking your technicians and your operators, by the way, and involving them in the system level critical thinking skills to be knowledgeable, not just qualified. So this is our approach. And just to give you an idea from a scalability standpoint of this, we have a total of 2 operators who are full-time in our organization and 2 full-time maintenance technicians. We are able to maintain a fleet of, again, just at 100 megawatts across 27 facilities and operate that profitably and operate that with very high availability in excess of 98.5%. And so this model has proved very effective for us year over year, and we continue to make tweaks to it, both in our system, our software and hardware solutions, but also just in our business processes and approach. So with that, I will happily take any questions that anyone has.
Brad, thank you very much. And for everybody on the call, let me suggest that you have a question to drop it in the chat box and we'll address it. Brad, there actually is one question there already from one individual who wants a technical question in terms of how do you switch off electricity production at a PV site, since when the sun's shining, it's producing a voltage. So how do you deal with that?
How do you switch off? So I think it matters which electricity you're talking about. So if the facility is connected to a utility grid, there is usually some type of a medium voltage breaker there where you can isolate yourself from the grid. But to your point, solar modules themselves do not have off switches. And so as long as there are photons interacting with the module P&N layer there, you are creating a voltage potential. And the modules, if they have a circuit to deliver that power onto, they will. When the grid is not available, though, so if you've opened up a GOAB switch or fuses or a medium voltage breaker, the inverters, which convert that DC energy into AC energy, they also have disconnect switches inside them. And so while the modules still have the potential to provide voltage and power, they are now an open circuit. And so there is no longer any power actively flowing in the system at that point in time.
Thank you. And a second question was, what's your optimal service radius?
So from an operations and maintenance perspective, we stay in the Carolinas and in Virginia, and that has been more of a business decision for ourselves. That said, though, we do provide operations services to folks where maybe an EPC, for instance, has their own electrical and commissioning team and they have warranties. And we will provide the back office operations of watching the alarms and providing the reporting and helping dispatch and plan their technicians for them. So when we do not have boots on the ground within or outside of our radius, we do support operations services for others and help them be successful with their maintenance strategy.
Okay. And just let me remind, if you have a question, please drop it in the chat and we'll go. Brad, I have a few I'll ask while folks are typing.
Sure.
One of the issues that we face with increasing penetration of solar on the grid is the interaction of essentially intermittent generation with the grid. Right now, I presume all the facilities you have are qualifying facilities, so the PPA is a must-take obligation on the part of the utility. But as you look at a world in which there may be, curtailment of solar, or there may be other controls, or you mentioned batteries. What do you see as sort of the data needs and the decision-making processes your operators are going to need to develop to work in that sort of future world?
Yeah, well, that's a great question, John. And I don't even think that's a what if. We already see that happening. So we work with several clients outside of the Carolinas now who deploy utility scale solar and utility scale energy storage for a variety of purposes. University and school, peak shaving, demand reduction, smoothing applications. We are seeing a lot of people coming to us asking about ancillary service response, including real-time market participation with local marginalized prices in the 5-minute real-time market. And so there is just tremendous interest out there in taking what has, as you referred to it, as intermittent resource and using storage to make it firmable to make it forecastable, and to make it dispatchable. And so those projects are already happening. And we've been very successful using our controls platform to bring that type of capability down to smaller and smaller facilities. We have a 5 megawatt facility with a 3 megawatt hour battery, for instance, operating in one of those demand reduction real-time control situations and responding to utility 1547 type of power plant control signals as well. And so those are very real and very much happening. And we look forward to the Carolinas, utilities to adopt standards that allow that type of free market participation for renewables in this market.
Okay. We have another question asking about what's the largest size facility that you're managing, and a follow-on question to that in terms of how efficient is it to store energy? And I would just add to that, how cost effective is it to store energy?
Yeah. So the largest facility that we deal with right now is 29 megawatts DC, 20 megawatts AC. It's actually interconnected here in the Carolinas. We do have product that we do not own and operate ourselves that is just below 50 megawatts, though, elsewhere in the United States right now. And as far as how efficient is it to store energy, I'll be honest, I don't track the current metrics here. Where we have dealt with lithium ion or similar, lithium variant chemical technologies, I want to say that the general round trip efficiency is around 80%. It might be a little bit higher than that, but I think 78% conservatively is what I've seen in a lot of the models. There are a lot of different energy storage technologies out there that we have not had direct experience with, and so I do think that varies. And as far as how economically efficient storage is, I think that just has to do with what are you doing with it. So if you're if you're successful in reducing your demand, and that's 50% of your bill, and you're a large industrial, or like a college campus with lighting and HVAC, I think it can pay for itself pretty quickly. So.
And another question regarding expanding control strategies to provide both storage and resiliency, and or possible microgrid operation. Do you see automation or a manual call center approach to providing those sorts of services?
Yeah, so let's see, it's a couple different things here. So storage resilience and possible microgrid operability. Yes. So as long as your inverters and batteries are capable of grid forming and operating without the grid as a reference, a microgrid doesn't really look any different to us personally as a grid connected generator. It's just the grid reference is coming internally. We actually do have a couple microgrids up and running now, one in New Mexico for a state park. Again, out in Colorado, we have a university campus that is capable of operating as a microgrid when they're disconnected. And as far as automation, staffed call centers, so artificial intelligence and machine learning is really amazingly impressive. As a new EV car owner that has some driving features on it, I'm really blown away with how far all that's come. I don't know that I'm ready to turn over the plant operations completely to a machine, but I do think that machines can definitely help us sift through the data to make it, more actionable, and certainly help operators make the best decision possible. So I see that automation and staffing as being, the automation providing more of an augmentation to really knowledgeable staff. But I think it's important to keep people in the loop, and so.
And it looks like we got a little bit of conversation going on energy arbitrage,
Yep.
and particularly utilities and the rates they offer. Could you speak probably to the generic issue, if you're on a time of use rate, for example, what opportunities are there?
Yeah, so load shifting, especially out in the West. Before I came to North Carolina, I was with some larger companies where they did not necessarily have storage, but they were architecting sites with trackers and slightly westward facing azimuths in order to try to shift the solar peak into the areas of day where the time of use rates were, in some case triple or more. And so where the markets allow for load shifting, I think that renewable generation, especially as you said, as it gets more penetration, where one intermittent facility does not necessarily mean an aggregate intermittent resource, where you have a lot of facilities geographically spread out, providing to the grid. You actually kind of very stable generation across regional diversity. And so as long as the market supports it, I certainly think that renewables play a part in that.
Mm-hmm. I would just observe that design of putting the solar arrays to the west of south seemed to always rub the engineers wrong. That had to understand you're designing to maximize revenue, not maximize production.
That's right. Yes. Yeah.
The question about commercial rooftop systems, and if so, can you accommodate that?
Yes, we can accommodate commercial rooftop systems. We see a lot of things, whether they be floating solar arrays. There's a new company out now that has a completely ground-mounted flat array where they have no pitch to it at all. So there's just a lot of really, I think, exciting things where people are not afraid to innovate in this space and really see what's possible. And so I hope that our market opportunities also continue to develop in order to allow continued penetration for a safe, reliable, and cost-effective energy future.
And can you speak to some of the tools and methods necessary to integrate to the grid? And I'm thinking here primarily of distribution portion of the grid that may be maxing out or near its maximum capacity, and the intermittency and other possible power quality problems that may come from current inrush on transformers and the like may have an impact on other users of the grid. How do you ameliorate those sorts of issues?
Yeah, so as penetration of renewables has become greater over the past half decade that our company has been growing, we have really been challenged to support our customers in making sure that these facilities can come online with appropriate capacity. Oftentimes at the end of very weak distribution feeders. You mentioned Inrush Current, which is something that even a lot of very seasoned engineers have not heard about. We had not heard about it originally, but this is a phenomenon where when you are very far away from a substation and the voltage on the line, the distribution line is essentially already low or lacking, support. And when you turn on megawatts or MVAs worth of transformers and they magnetize, they look like a very large instantaneous load. And I think the easiest analogy for people who aren't electrical engineers or familiar with this is if you've ever been in a building where the lights flicker when the HVAC unit kicks on, that is a form of voltage sag caused by inrush current. When the HVAC motors, the pumps, the compressors turn on, they draw a lot of current, voltage goes down, and you get light flicker, and things sometimes will power on and power off. In those commercial settings, though, they have devices called soft starts, and these are capacitors that essentially provide the extra kick that the motors need in order to overcome that very fast current draw. And in our case, we have a product that we call our Clear Sky Plus, and it has a special transformer in it that acts like a choke, and it essentially removes the inrush current phenomenon by limiting how much current can flow into the site during that initial magnetization process. Just to use some figurative numbers for anybody that are lost in the electrical jargon there, maybe an inrush of 400 amps would cause a voltage sag normally. And when our system is in place, we reduce that to less than 8 amps. And that 8 amp draw is essentially invisible on the grid, and there is no power quality issue at that point.
Okay. A question about your business model and finding shared service co-ops that basically provide, it's sort of an app, if you will, it's sort of the Uber approach to solar maintenance. Do you see that as a threat to your business?
No, not at all, actually. So although we have O&M as part of our business, and it's in our name, Solar Operations Solutions, we actually are not looking to grow our maintenance footprint. We're very comfortable in the Southeast. We see more opportunities, though, working for groups, again, like EPCs or owners, who want to centralize their maintenance and have a better standard of, what testing is being done and what reporting is being done. And they find themselves in a little bit more of a situation where they really need guidance to stand up a good O&M program, and they need good systems and tools. And so that's where we've focused on products, including SCADA and weather station and interconnection products to make sure that you're getting good, reliable data from the sites and things are properly instrumented. And then a software platform that we refer to as our intelligent platform that allows for seamless solar, storage, and wind integration into a single platform, and essentially providing a back office software platform, and then, of course, professional support services. So if someone is out there developing an Uber for O&M app, I say that's great. We would love to support you with that.
All right. A question about AC production. Just asking for some more information on that.
AC production. Sorry, is this in the? Oh, I'm sorry. I didn't scroll on the chat. Let's see if I mentioned 6 megawatts AC produced. So can you please elaborate more on AC production? Okay. Sure. So AC production, alternating current. So solar plants, although they are DC at the module level, when the inverter converts it into alternating current, it is typically either a two-phase system like you would see in your house, so maybe 240, so 120 split phase, or more often in the utility scale side or commercial side, we see three-phase. So you would be injecting at 480 volts or above. And injecting directly into the building below behind the meter, behind the transformer, so to speak, on the building side. Or for most of the sites that we deal with, you're injecting AC directly into the grid, where you go through a step-up transformer and you step up to some medium voltage, whether it be 12.47, 22.86, 34.5, etc. And so you're taking that DC through an inverter to AC, and then stepping up the voltage to whatever your interconnecting system is. I'm not sure if that answered your system, your question.
We'll ask that individual to.
Okay.
Did. Thanks.
Okay. All right. Thanks.
Want to ask, as we think about more penetration of solar, and particularly as solar operators, owners are operating in markets and may actually have an energy trading desk. What sorts of tools do you see, or can you provide that help those traders get a good understanding of the energy production that they might be able to see, and therefore play more effectively in the markets that they're operating in?
Yeah, so we think this is actually really tremendously important for the industry as we move away from, as you mentioned earlier, John, qualified facilities, which are reliant on PPAs, to really now having, intermittent renewable energy, potentially backed by storage, in order to be able to firm production, where now you can use the battery as a backstop. To be able to, or just have enough headroom on your solar to be able to say, for the next hour, or day ahead based on the weather forecast, I feel confident that I can deliver 2 firm megawatts, for instance, of power during certain hours of the day. And so as you introduce controls, control platforms into these plants, and especially where you have storage, after you have some basic operating going on, where you feel that the plant is resilient and reliable, I think the opportunities for market participation by renewable facilities is imminent. That will happen, no doubt. Yeah.
And what sort of challenges or the like do you anticipate? Because obviously you need to understand the status of the site and the equipment on the site, and you need to have a forecast of the irradiance that you're going to expect on the site. Any thoughts of how you integrate that information into what then becomes usable information to an energy trader?
There are already very good established availability metrics mostly around inverters and things. But as you saw in some of the slides, we have a real-time expected calculation that is looking at the plant. It's looking at the inverters, the trackers, the irradiance, and it's giving us a very accurate, oftentimes plus or minus 1% type of accuracy of where the plant is capable of producing and where it should be producing. As we take a look at a radiance forecast in the market, which we've worked with a handful of providers to date on, we see a lot of room for improvement of those services. But I do believe that those will get there. And another thing that we see, John, is we see, in the past, people have installed very high DC to AC ratios. That is to install more DC than you actually, more panels than you actually need. And there's been a host of reasons for that. Good economics on the modules, hedging against module degradation, et cetera. But another trend that we see now, again, with controls coming to these solar plants, is the concept of an AC overbuild, having more AC than what your PPA will actually support. And a great example of this is either with string inverters or with just very large central inverters. Maybe I have a 5 megawatt PPA, but I can only buy two 3 megawatt inverters. And so I really have 6 megawatts of production sitting there. So using controls, you can manage that 6 megawatts to stay within your 5 megawatt PPA. But what it means is that you can reach your 5 megawatts much earlier in the day. And so you can actually get, kind of wider shoulders, similar to what you would with a tracker. And if one of your inverters fails, so 3 megawatts go offline, you can ramp the other inverter up to its maximum capacity, and so I think that as we see more AC overbuild coupled with real-time control, and then coupled with batteries, you really just now have a lot more resiliency with the plants. It would be very easy and safe to forecast 2 megawatts, for instance, in the hour ahead, or 5 minute ahead market. When you have a 6 megawatt overbuilt facility, you just have a lot of overhead there to play with. And so
one of the other developments you see in the market is the rise of corporate customers who, and they've been around for a number of years, basically wanting to offset, hitting their ESG objectives and offsetting their electricity use. But increasingly, what you're seeing are ones that simply don't want to offset it. They want to match it effectively hour for hour. Mm-hmm. What kind of challenges and how would you address those challenges, in dealing with customers of that sort?
Yeah, so this is common, and we do have customers that approach us for this. I think this is an area where there needs to be a better model for those customers to maybe understand what it is they're trying to achieve. They tend to look at it a lot of times as more of a singular program. I'm just doing demand reduction, or like you said, I'm just trying to offset a percentage of my, my energy. But again, I think if maybe they're not willing to take the dive into a complete, microgrid type of setup just because of the capacity or the cost. But we see a lot of people, I'll call it dabbling in this, where they're starting to do pilot projects and they're starting to try to understand it. And does it integrate with their building management systems, for instance, depending on who the customer is. And so we saw the same type of experimentation 10 years ago, with the utilities, large utilities out west starting to kind of say, I'll do a 2 megawatt here and a 10 megawatt there. And then, a couple years later, they're building 100 megawatt facilities. Certainly, we've seen that in the Southeast, with Duke Energy here as well. Small facilities at first, third parties doing it, and now very large, transmission level interconnected facilities. So I think that as people start to realize what they can do with renewable energy and how it fits into their business planning, whether it be existing structures that they have, or as they plan for real estate or reuse of buildings or new buildings, looking at Apple's campus, they've built a very large donut. It's covered in solar panels, right? So that wasn't a mistake. And so they thought about it from day one. And so I think we're going to see the idea of incorporating renewables, whether it be, energy storage or alternative fuel cells, wind, solar, et cetera, all the above, into the ethos of how they plan to build their businesses from an energy resiliency standpoint. And but right now, I think people are experimenting, and it's exciting.
That experimentation, obviously suggests the industry is very young. There are very few solar facilities, utility scale solar facilities that are more than 10 years old. What do you see as some of the challenges as solar facilities, I'm thinking large utility scale, age?
Yeah, so we have a lot of clients with older systems like this where they got in early and they thought they were doing a really good thing, but as technology has moved on and gotten better, their facility unfortunately has eroded. And so some of the things that we take for granted today as best practice or better technology or better approaches just were simply not known or not available at the time. There is a rising class of businesses. I will actually give a plug here to one right out in Charleston, South Carolina, Solar Support, not related to ourselves, although we're all named kind of similarly. Their entire business model, though, is to come in and help companies retrofit aging plants to essentially do what they call a recharge. That recharge may be replacing the modules. It might be replacing the inverters. It might be an all of the above, just taking advantage of the PPA and rebuilding the plant. We work with them oftentimes on implementing new controls. So replacing monitoring systems that don't exist in the market or don't work anymore. And so I like with anything, as you have equipment that ages and falls out of warranty, and companies become unavailable to support them when something catastrophically fails. If you cannot fix it through aftermarket parts or technicians' knowledge, then you have to replace it. And so I think that is a huge challenge for people that got into the industry early and have maybe had less than great experiences with some of these early systems. That said, though, the systems that are going in today, even the worst system going in today, is better than any system that probably went in 10 years ago, even with the best intentions. And so, and a lot of those systems that went in 10 years ago are still chugging away. They're still doing pretty well. And so it's rare for us to come across something that has suffered a catastrophic failure. We certainly see a lot of things that could use improvement, but even the early facilities that were done maybe without all the knowledge or benefit of today's technology still operate pretty well. So.
Speaking of catastrophic failure, what sort of issues have you run into when a hurricane rolls through the area that you serve?
So, I actually grew up in the Midwest, in the Rust Belt, as they like to call it. And then I moved out to Arizona for a while. So when I came here with my family 7 years ago, I looked at hurricanes as a really big deal. Yet I was probably a little oversensitive to it. 7 years later, though, well, I am absolutely certain that hurricanes can and will do a lot of damage to certain sites, much like if a tornado hits you just the right way. A lot of these sites, we have several sites near and on the coast that have not experienced any problems. Our solar sites are usually first to restore once the grid is available after an area has been shut down. Outside of maybe a handful of modules coming loose off the racks, or maybe the larger problem is debris flying into the array, maybe a rooftop, getting torn apart, or a tree, or something. In large part, these sites actually weather these storms quite well. Especially sites with trackers where they can be moved into position so that they they are essentially facing the wind in a way where the airflow, the prevailing wind just passes over them. So these sites are actually incredibly resilient to hurricanes.
It's my observation that after a storm, they're offline most often because the grid's not servicing them.
That's right. Yeah.
Well, I've exhausted all my questions, Brad. Thank you very much. And it appears that we don't have any others coming through. So we really appreciate your presentation here today. This is very, very informative.
Okay, well, great. Well, I'll be happy to PDF it and provide it for anybody who would like to download it.
Monica,
do you have any closing thoughts or comments?
I don't. It was very interesting and very engaging. So thank you very much, Brad. Thank you, John.
And let me remind everybody that this is one of a series that we E4 puts on, so there will be more coming. And Jess, help me remember the date of the next one. Have we set the date yet?
August 1st.
August 1st. So everybody keep your eyes open. We'll have another interesting company sort of at the forefront of the energy industry here in the Carolinas for August 1. You can watch for a note from us if you're on our mailing list, or simply visit the E4 Carolinas website, and all upcoming events are listed there as well.